Hello and welcome to tutorial number 14 about database design, or as we call it, database normalization. At some point within your coding career, you're going to need to use databases, whether that's inserting data into databases or removing or taking data from databases and analyzing it. It's called database normalization, and this is the process which allows you to remove redundant data within a database. A properly normalized database should have the following characteristics: absence of redundancy, minimal use of null values, minimal loss of information. The key thing here is item number one, absence of redundancy, or the reduction of duplication. And we're going to give a little example of how normalization works. So we're going to start off with a record from a library. This is a record of a book. And you'll see that the book is stored in the library. It has a number. This is the unique reference number for the book. It has a title, has a category, and this book, being about football, is in 3 different categories. It has the author, the guidance range, and the type of book. Now this is the unique number, and it's called the primary key. As that's unique, that will always reference this book. But at the moment there is duplication in this database, and we will go through this. The first thing we're going to look at is we'll split the data out into the individual records. Now the book number is the same, the title is the same, but the category is different. Author is the same, age range is the same, and the hardback. So if we were filing this manually, you would have 3 records for this database, for this book, sorry, which is not good. So we need to remove the redundancy. So the first thing we need to do is look at the category table, because that's the one that's causing the main issue. So as you can see, the category is not unique to this book. There could be several books with the category sport. There could be several books of the bad football teams. So what we need to do is create a new database table, and we're going to call it book category. And within that book category, you would have the foreign key, sorry, the primary key. So this is the primary key that every book that has a category of 5 becomes linked to sports. Then back in our original database table, we have this key, which is the primary key here. Within this record, it's now called the foreign key. So the primary key of this table links to the book, and the foreign key links to the primary key of the book category ID. So at the moment, we still have the same 3 records, because all we're doing is replacing the name of the category with a newly created foreign key. So that hasn't reduced the redundancy yet. To reduce redundancy, what we need to do is remove the product category from our original book record, because it's no longer unique, therefore it's causing the duplication of data. So we have the newly created table for the book category, and we have the foreign key in the original book table. What we do now is create a new table, which is going to be called book and categories. So we bring in, this is the primary key, but the main thing is having 2 foreign keys within this. So it's a joining table. So we have the book number, which is the primary key from the book table, and with the category ID, which is the primary key from the book table. This now links. So every time we want to search for books that are within a sports category, we search the book category ID for the ID 5, which brings up the book number, which then brings up the book, which then moves on to the next page. So now we're looking at the author. The author is unique. In our original book table, the author is completely unique. So we need to create a table for authors, because Mr. Mourinho may have written more than 1 book. He may write 1, he might write 10. He may even change his name at some point, so we need to make sure we can control that. So we create a new database table called book author. This contains individual unique authors. So again, this has a primary key, and then we go back to our original database table for book, and we add this in. So this is the foreign key going in, linking back. So we know book number, this has the author 1. So we now created the author table to remove duplication. Now we need to look at the age range. Again, this is not unique. Many books could have the age range 12 plus. So we need to create a new table called book age. Create the primary key, go back to our original table, put the foreign key in. Here we go. Now this could be at some point in the future this book is reclassified, or the age ranges may change. So say the classification is 12 plus, 15 plus, 18 plus. Everything needs to move from 12 plus to 13 plus. All you do is change the record in this table, and it automatically updates the whole database for that. So you're not having to go into each individual record to do that. So now we've got 1 more column left to move, which is the book type. So it's hardback. So we create a new table called hardback. So it could be, sorry, it's book type. We have hardback, softback, it could be digital, it could be PDF, it could be anything. And again, this creates a primary key. We go back to our original table and put in the foreign key. Now you'll see the original 3 records we had for this database are all exactly the same. So what we have done is removed the redundancy for this database. So this is what we've created. From having one book record, we've now created a database that looks like the following. And this is purely just looking at the data. So from here we can see book number 339. We know we find a category, we search books and category. It links to these 3 categories. If we're looking for all bad football teams, we search this table. For number 7, we find the book number. With a book number, we can find the book details. If we want to find every book by Jose Mourinho, we search the book table for everything with a book number of 1. If we want to find every hardback, we go book type 1. For example, if you look up this book record, you may think, what type is this book? Straight away it's hardback. What age range is it? Oh, it's 1, 12 plus. So from this actual structure, we can review the whole database based on one data record. Now, if we go back to the original table, this is how it should look on paper. So this is the data record here. This is what's actually physically stored in the database. But when you design a database, you would write it here. So this table is called book. You have the book number, the book title, a unique piece of text. The book author, again, is the foreign ID. The book age, again, foreign ID, book type, foreign ID, because they all link to different tables. And then this is what it looks like for the other tables with the data and with the actual database design. This is the data record, this is the structure. Table author, table book age, book category, book type. So if you add more types or book ages, the structure stays the same. It links back to the original record. And then we look at what it actually looks like in terms of a database structure. So if you were actually designing a database, this is what it would look like on paper. No records, no details, no information, purely the structure. So we have the tables book, book age, book category links, book author, book type, and category. We've got adjudicator book type, my mistake. But overall, every one of these tables link to each other. From the book type ID, you can find the type. From the category, you can find categories and books. So this is how you would design a database and what it would look like. And here's a challenge for you. Based on what we've shown you so far, you can actually try and design your own database. And this is a real world scenario. It's a practical exercise involving a database. The database is needed for a shop to better organise its products and its customer records. The following information is available, and your challenge is to convert this into a database design and add as many tables as needed to make the database more useful and, of course, reduce redundant information. So here's the record. This is actually going to be a customer record from a shoe shop, and it has details of the customer, so it knows my name, my address, email and details, and it knows the product. Now the idea is to try and link these 2 tables, this information, into a perfectly designed database. So you've got to think about items that are duplicate, items that are unique, items that may change. For example, a little tip, like the brand name. Will the brand name always be linked to that pair of trainers, or will it be linked to other pairs of trainers? All the other details here. So, study this record now. I'm going to wait 2 or 3 seconds, so I suggest you pause the video now before I show you the results. Okay, so here are the results. This is the answer to the actual database design. So from those simple 2 pieces of information on the customer and the product, we've created this. So we have the customer. Now on the customer ID is the primary. The forename and the surname are unique, and the address, because these 3 items always link back to the customer. The state ID, where they live, that's not unique, because many people could have the state. So we've created a new table called state. Again, with the country ID, country is not unique to a customer, so country has to be created as a separate table and a foreign key. Telephone number and email is actually linked purely to the customer. Now, PCMID is the preferred contact method. Again, that's not unique. Contact, email, telephone, whatever, that is not unique. So we create a new table for that, and that becomes a foreign key. With the product, we have the product ID. That's the primary ID. The name of the product is unique to that product. The brand is not unique because there could be many trainers with that brand. So we create a new brand table with the brand name. Category ID, again, That's not unique. So we have a new category table. But remember, same as my example, this product may appear in many categories. So we would create a product category table that has the primary key and 2 foreign IDs linking the product to the category. So this product could be in multiple categories. The price is unique. The stock level is unique. The recommended age for this product is not unique. So again, we've created a new table for the recommended age. And the currency ID, again, is not unique because it could be available in many currencies. So again, we create a currency table. And then the rest of it all sort of makes sense. For example, the country, we've explained that. The state, contact method, age, category, brand. Product size, maybe we actually had a table here for product size. It comes in variable size and variable colours. So what we would actually then do is link the size of the product to the product. So this is a joining table and this is the size table, same as the colour. This is a unique colour table and this is linking the colour to the product. So for example, this trainer may come in 3 different colours. So what looks originally as a very simple data record becomes a very, very detailed database. And it's as simple as that. All you need to try and do in database design is to look for duplication and uniqueness. If you remove the duplication and focus on the uniqueness, you get a perfectly designed database. I know this may be very quick for lots of details, but running through database design is key to understanding how efficient coding works. I hope you enjoyed it. Thank you.